Hello, am I audible? And is my screen visible? Hello? Someone please let me know if I'm audible and if my screen is visible.
Yes, it's audible, audible.
Okay, thank you. So, good evening everyone. Welcome to this NPTEL live session for the course Deep Learning IIT Ropar. My name is Learning-IIT. I'm a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So, this is an extra session for this course. This is my 13th live session. So all 12 live sessions that I have done were on weekly topics, and this is the last live session. So in this live session we will discuss some practice problems on all the topics that were covered in this course. And if you have any other questions or queries, you can ask me during this session. So we'll start solving the practice problems first, and after that if you have any other questions or queries, then please feel free to ask me. So this is the first question. The perceptron given below takes two binary valued inputs. So values are between 0 and 1. These are the two binary valued inputs, x1 and x2. And this plus 1, this gives the bias of -10. Which of the following logical functions does it compute? So y is the output. So which logical function does it compute? There are four options: AND, OR, NAND, none of these. You can write your answers in the chat. So these are the two inputs, x1 and x2. Both the inputs are binary valued. Has anyone solved this question?
What is this +1, x1, x2? Okay, bias. Okay.
Yes.
Yes.
Plus 1 is for the bias. The value of the bias is -10. So to solve this question, first we have to write down the expression for y from this perceptron diagram and the weight and bias values. We can write that y is 1 y is 1 if 20x1 plus 20x2 minus 10 is greater than equals to 0 and 0 otherwise. So this is the this is basically the decision boundary 20x1 plus 20x2 minus 10, which we are getting from this weight and bias values. So now this 20x1 plus 20x1 plus 20x2 minus 10, so this expression is greater than 0, and this x1 and x2 both these variables are binary variables, so both of them belong to 0, 1. So if either of these variables x1 and x2 is 1, then we can see that this expression overall is positive, greater than 0. If x1 is 1 and x2 is 0, then it's 20 plus 0 minus 10, so overall it's 10, which is greater than 0. And same is the case when x2 is 1 and x1 is 0, so the overall term would still be greater than 0. And if x1 and x2 both are 1, in that case also it's 20 plus 20 minus 10, so it's still greater than 0. So if any one of these two variables is 1, then this overall expression is greater than 0. And so in that case the output would be 1. So if x1 if at least one of these two variables is 1, then the overall output is 1, and which is exactly same as OR gate, isn't it? So in OR gate, if one of those two, if at least one of these variables is 1 or true, then the overall expression is of the OR gate is true, and when both the variables are false or 0, then the overall output of the OR gate is 0. So same thing is happening in this perceptron, that when x1 and x2, when both of them are 1 or at least one of them are 1, then y is 1, otherwise y is 0. So it is actually computing OR gate. So this is how you have to compute which logical function a certain perceptron is computing. So you just have to first find out the decision boundary for which the output is 1, then analyze the decision boundary and try to find out which gate is similar to that, which logical gate is similar to that. So the correct output is 1. Correct output is B, OR gate. Is there any doubt in this question?
No, not.
Okay.
Thank you.
Now question 2. Consider the data given below. So this is the data. These are the x1 and x2 are the input features, and y is the target variable or the output variable here. So this is a classification problem. There are two classes, 1 and 0. So the question is it possible to classify every data point correctly using a perceptron algorithm of this dataset? So there are three options: yes, no, cannot be determined. So there are 4 data points, as you can see in this dataset. So is it possible to classify each of these 4 data points correctly using a perceptron algorithm? And these are the two features, x1 and x2. Y is the target variable or the output variable or the class level. Vandana Mahajan says no. Okay. So for this question, you first have to plot these points, roughly plot these points on a 2D coordinate system to visualize the points. You can also do it without visualization, but visualizing it would make it easier. And so first point is 5, 5. So this would be, let's say, somewhere here. The class is 1 for this question. Next point is 0, 7. So it would be somewhere here, and this is also class 1. Third point is 8, 0. So it will be somewhere here, and the class level is 0 for this one. And the last point is -1, 1. So it will be somewhere here. The class level is 0. So roughly these are the points. Now perceptron learning algorithm is a linear discriminant algorithm. Basically it creates a linear decision boundary. So if the points are linearly separable, then the perceptron learning algorithm can certainly classify all the data points correctly. And from this rough plotting of the 4 points, we can easily see that we can find a straight line like this red one that I just drew, which can be used as a decision boundary. All the points belonging to class 1 are above this red line, and all the points belonging to class 0 are below this red line. So this red straight line can certainly classify each of the data points correctly. And there are many other linear separators possible. This is also another one. You can have many such linear decision boundaries, but what we can see from this plotting is that it is possible to get at least one linear separator that can separate the two classes 1 and 0 in this data set. So if the points are linearly separable, then perceptron learning algorithm can certainly classify each of the data points correctly. So the correct answer would be yes. So you just have to check whether the points are linearly separable or not. If the points are linearly separable, then perceptron learning algorithm can certainly classify them correctly, each of the data points correctly. The correct answer would be yes. Now third question. For a function fx 5x square minus 4x minus 5, we use gradient descent algorithm to find its minimum. So if the initial value of x is 2 and learning rate is 0.02, what is the updated value of x after the second iteration? So you have to run the gradient descent algorithm for 2 iterations. First the iteration 1 and then iteration 2, and then what will be the updated value of the x after the 2 iterations. You want to find out the minimum for this function fx. So you have to take the derivative of this function and update the value of x accordingly. Vandana Mahajan says 3.6. Okay. So the update rule in gradient descent is the updated x should be the initial x minus eta. Eta is the learning rate, so this is the eta. Learning rate. Sorry. X is updated as x minus eta into f dash x. So the f dash x is computed on the initial value of x. So this f dash x in this case would be this is the function 5x square minus 4x minus 5. So the f dash x would be 5x 10x minus 4. So the initial value of x is 2, so it would be 20 minus 4, so there is 16. So after the first iteration, the value of x would be 2 minus eta is 0.02 into 16. So there will be 2 minus 0.32, which is 1.68. So this is after the first iteration. Now you have to run the same process for the second iteration. So now in the second iteration, the value of x has become 1.68. So the value of f dash x should be 10x minus 4. So now this x is 1.68. Value of x has changed in the second iteration. So it would be 10 into 1.68 minus 4. So this would be 16.8 minus 4, which is 12.8. So the new updated x after the second iteration would be value of x is now 1.68. So 1.68 minus eta is 0.02 and then 12.8 into 12.8. So you have to compute this expression, and if you compute this, you should get 1.424. So first you have to find the derivative, and then for the first iteration you put the value of initial x into alpha is the learning rate, alpha is same as eta, into f dash x, and then again do the same process for the second iteration, and in the second iteration value of x has changed, so f dash x would also change. So this is how you have to compute the minimum of a function using gradient descent. Now question 4. For the Adagrad algorithm, consider the gradient delta wt. So this is the gradient of w, which is 0.4. Vt minus 1, which is the history. It stores the history of gradient of wt squared actually. Then the epsilon, eta values are also given, and the current weight value wt is 1.0. What is the updated weight? So what is the updated weight after one update of the Adagrad algorithm? So many of you might not remember the update rule for ADAGRAD because it's a lengthy expression. So I will just show you the steps. So in ADAGRAD, Wt plus 1 is updated as Wt minus eta, which is the learning rate, divided by root over Vt plus epsilon into gradient of Wt. Now this Vt is also updated in every step. So this Vt is Vt minus 1 plus gradient of Wt whole squared. So this Vt is it basically accumulates the square of the gradient of W in every time step, and then this Wt plus 1 is updated as Wt minus eta divided by square root of Vt plus epsilon into gradient of Wt. So now we have all the values of this update rule. Eta first we need to compute this Vt. First we need to compute Vt from Vt plus 1 and the gradient of Wt. So this Vt plus 1 is given here 0.2 and gradient of Wt is given here 0.4. So using this we can find out value of Vt. Now for the updated weight Wt plus 1, we know the value of Wt, which is 1.0. Eta is also given as 0.1. This Vt here comes from this expression, which we will compute before the update rule, and this epsilon is 0.1 and gradient of W is given here, which is 0.4. So all the values we already have, we just have to plug in all the values in this expression. First we have to compute Vt from Vt minus 1, then we have to compute the updated Wt plus 1. So if we input all these values, we will see that Vt first comes out as 0.36 and then Wt plus 1 comes out as 0.941. So you just have to remember these two expressions for Vt and Wt plus 1. Now question 5. If the dimension of the input layer in an overcomplete autoencoder is 7, what is the possible dimension of the hidden layer for that autoencoder? There are 4 options: 3, 1, 4, 10. Vandana says option D, 10. Okay. Anyone else? So the correct answer is D10. So in an overcomplete autoencoder, the number of hidden units in the number of units in the hidden layer is more than the number of units in the input layer. So here the input layer contains 7 units. So the only option which has more than 7 units in the hidden layer is option D10. Now all the other options 3, 1, 4 are lesser than 7, so those cannot be correct. So only possible dimension out of these 4 options is 10. And similarly in an undercomplete autoencoder, the number of units in the hidden layer would be lesser than the number of input layers. So that is in undercomplete autoencoder. This in this question, for an overcomplete autoencoder, it should be more than 7. Option D, 10 is the correct answer. Now question 6. So statement is given that ReLU activation function is a linear function. So whether it's true or false, you have to state. Vandana says option B, false. Okay. Anyone else? Correct answer is false. So ReLU activation functions looks something like this. So there are two linear segments present in the whole ReLU function, but overall this is not one straight line that we can say it is a linear function. So this is not a linear function, and it can bring non-linearity in the neural network because it is not a linear function. So correct answer is false, B. Now question 7. We have 1000 words in a vocabulary. What would be the size of the one-hot encoded vector for a given word of this vocabulary? There are 4 options: 1000, 2 to the power 1000, 10 to the power 1000, 10,000. Vandana says option B, 2 to the power 1000. Okay. Akila Ishwari says 1000. So the correct answer is A, 1000. So in a one-hot encoded vector, we have one entry for every word. So if this is the overall one-hot encoded vector, this is the vector. This entry is for the first word, this entry is for the second word, this entry is for the third word. So if there are n words, so the one-hot encoded vector would be of length n or size n. Each entry is for a specific word in the vocabulary, and if that word is present, then that entry would be 1. All the other entries would be 0. So if there are 1000 words in the vocabulary, then the size or length of the one-hot encoded vector for each word using that vocabulary is 1000. So option A, 1000 is the correct answer. Now question 8. So this is on convolutional neural networks or CNN. 20 filters of size 5 cross 5 is applied to an image of size 100 cross 100 with 0 padding and stride of 5. The image is an RGB image. The depth of the filter is same as the depth of the image. What will be the volume of the final image or the shape of the final image? So there are 4 options: 19 by 19 by 20, 20 by 20 by 20, 20 by 19 by 20, 5 by 20 by 100. So the shape of the input image is 100 by 100. So let's say if the width is 100, the height is also 100. W cross H is the shape of the input image, and one layer of CNN transforms this image into W1 cross H1 shape. So W1 and H1 can be computed as W1 is W minus F. F is the shape of the filter, which is 5 here. So F is 5. W minus F plus 2P. P is padding, which is 0 padding we are using, divided by S. S is this stride, which is also 5, plus 1. So this is the new width, W1. Similarly, H1 can also be computed as, the expression remains the same. So H minus F plus 2P divided by S plus 1. So this W is 100, F is 5, P is 0, S is 5. And if you plug in all these values, so W1 would be 100 minus 5 divided by 5 plus 1, which is 95 by 5 plus 1, which is 19 plus 1 equals to 20. And similarly, height would also be 20 if you plug in all this, because H is also 100 and all the other variables are also same. So H1 would also be 20. So height would be 20, width would be 20. Now what would be the depth? So depth would always be the number of filters. For the input image, it was an RGB image, so the depth of the input image was 3. This is an RGB image, so volume or shape of the input image was actually 100 by 100 by 3 for the input image. But in the output image, the depth would always be same as the number of filters used. So 20 filters of size 5 by 5 is used. So 20 filters are used, so the depth would always be 20. So the shape would be W1, which is 20, H1, which is also 20, into depth, which is 20. So 20 by 20 by 20. Option B is the correct answer. So is it understandable?
Yes.
Yes, yes.
Okay. So correct answer is option B. Now question 9. So this is again on convolution. Compute the output of the following convolution with stride equals to 2, padding equals to 0. So this is the input image. This is a 4 by 4 input image, and the kernel is given, which is of 2 by 2 shape. So what will be the output of this convolution if we convolve this kernel with this input with stride 2 and padding 0? Vandana says 3557. Okay. So the kernel is a 2 by 2 matrix. So first we will see the 2 by 2 first 2 by 2 window in the input. So this is the first 2 by 2 window in the input, the red box that I have drawn, and we will do pointwise multiplication with the kernel of this 2 by 2 window. This 1 into 1, then this 1 into 2, 0 into 2, 1 into 3, and then add all these multiplications. So this is 1 into 1 plus 2 into 1 plus 2 into 0 plus 3 into 1. So it would be 1 plus 2 plus 3, which is 6. So this is the first entry in the output matrix. So if this is the output matrix, first entry would be 6.
So how do we know like what type of kernel is used? Is it average, max, or is it?
No, the what you are saying is pooling layer. For pooling you have average pooling, max pooling, but for this is convolution layer. So for convolution you will always do pointwise multiplication with the kernel and take the sum of those.
Okay, thank you.
Yeah, so what we are saying is pooling. In pooling layer there are many different types of pooling, but convolution operation is always same, that you do pointwise multiplication with the 2 by 2 window in the input and then take sum of those. Now this is for the first 2 by 2 window in the input. Now we will go to the second 2 by 2 window. So with stride 2, this is the second 2 by 2 window. If this was stride 1, then the next 2 by 2 window would have been different. With stride 1, next 2 by 2 window would have been this, but we have stride equals 2 here. So the next 2 by 2 window would be this one. So we will with stride 2 we will go to the next 2 by 2 window, which is this red box. Now we will do the multiplication again, pointwise multiplication. These 4 points would be multiplied pointwise, and if we do the multiplication and take the sum of those multiplications, it will be 3 into 1 plus 4 into 1 plus 4 into 0 plus 5 into 1. So it should be 3 plus 4 plus 5, which is 12. So the next entry would be 12. Now we will do the same process for the next 2 by 2 window, which is this one. With stride 2, this would be the next 2 by 2 window. Again do the same process, pointwise multiplication and taking the sum. And if we do that, the third entry in the output would be 3 plus 4 plus 5, which is 12 again. And finally the last 2 by 2 window in the input image would be this one. And again this pointwise multiplication, we will get 5 plus 6 by plus 7, which is 18. So this is the output matrix: 6, 12, 12, 18. Is it fine? Is there any doubt in this question?
Okay, sir.
Okay. This is the output. So basically your kernel has 1, 1, 1, 1 in these 3 positions. That's why you have to just add these positional values 1, 2, 3. Similarly in the next window you have to add 3, 4, 5, because these places are 1 and this place is 0. So these 2, these 4 are never added. Now moving on to the next question. We construct an RNN for the sentiment analysis of text, where a text can have positive sentiment and negative sentiment. So there are two possible outputs of the RNN. Suppose the dimensions of the one hotted encoded words xt is r to the power 20 into 1, and dimension of the state vector st is r to the power 100 into 1. So what is the total number of parameters in the RNN unit or the network? And you can ignore the biases in the network. Don't include the biases in the number of parameters. So xt is a 20 cross 1 vector. St is a 100 cross 1 vector, and there are two outputs possible: positive sentiments, negative sentiments. The output is of 2 units. So in RNN there are 3 matrices of parameters, 3 weight matrices basically, and there are several biases which we will not include in this case. So if this is the RNN unit, this is the input xt, this is the output yt, and this is the state variable which goes back into the RNN unit. So the xt goes via matrix U, the st is multiplied by matrix W, and the output yt goes via this matrix V, and the expressions or the equations are st plus 1 equals st equals st minus 1 u xt plus w st minus 1, some sigma of that. Sigma we don't really have to think about, and then yt is the actual output. There is also some activation function sigma of v of st. So this w u w v, these are the weight matrices. You have to find out the number of parameters in these weight matrices. So the u this u is from xt to st, so the shape of u has to be, so this xt, length of xt and st are given in this question. So length of the shape of u has to be 100 into 20. So these many parameters are there in U. W will contain W is from st minus 1 to st. So shape of st minus 1 and st are same, just that the time steps are different. So this 100 by 100, so number of parameters in W would be 100 cross 100. And this V is from st to yt. So shape of st is 100 into 1, and y, there are two outputs, positive sentiment and negative sentiment. So it will be 2 into 100. So you have to add these values. So 100 into 20 plus 100 into 100 plus 2 into 100. And these are the three shape of the three matrices, number of parameters in each of the matrices, and the total number of parameters would be 12,200. Yeah, so these were the practice problems that I wanted to discuss in this live session. And now if you have any other questions or queries, you can ask me.
Actually, the syllabus is too much, and there are so many formulas and derivations. Like, what to study?
Yeah, it is fast. I mean, 12-week course, so there are 12 different modules in that course. So the syllabus is certainly very, vast. But the you should focus on.
Yeah, syllabus is vast, but syllabus is covered. But like for from exam point of view, like what are the main important topics?
My suggestion would be that if you try to solve the assignment questions properly without looking at the answers, then you will be able to score quite well. Many questions would be outside the assignments also. Those will not be at all similar to the assignments, but many questions would be similar to the assignment questions. Not the exact assignment questions would come, but similar questions would come from assignments. So if you can solve these assignment questions properly, then you will be able to solve most of the questions in the exam.
Okay, thank you.
Okay.
Also, like these formulas and derivations, like for ADA grad, and then for this LSTM, there are many formulas that are there based on the time. So gates and all those things, we have to learn these.
Yeah, RNN, LSTM, and gated recurrent unit. These certainly you have to uh, learn, and also if you have to memorize if you need, because the LSTM RNN parts are really important. Many questions might come from those. What are expressions of for different gates? What are the dimensions for different matrices on those gates? Weight matrices. This U, W, V are there, and what will be the dimension of a specific gate in the LSTM. So those you have to understand and memorize if you need, because those are really important for RNN and LSTM.
And for others, like gradient descent and all, also.
Those, you should be able to memorize some of them, because questions might come. I don't know whether questions would come from those, but questions might come from different gradient descent algorithms like RMS prop, ADAGRAD, ADAM optimizer. So questions might come, but it's actually difficult to memorize all those expressions in the gradient descent, because the expressions are so similar in those algorithms. So it might be difficult, but it would be good if you can memorize the expressions. But for LSTM RNN, the expressions, if you understand where the connections are coming out and where the connections are getting into, then you will be able to visualize the gates properly. So for those LSTM RNN, those are not that difficult to memorize or understand. So is there any other questions?
It will be the sir go last class, sir.
Yeah, it is my last class. Yes.
Okay, thank you so much, sir.
Thank you. Thank you everyone for joining.
Yes, yes.
Yeah, thank you.
Thank you. And best of luck for your exams, final exams.
Okay,
Thank
thank
you.
you. Ahmed sir,
Yes.
sir, actually, do you know Suprit Sahu?
Suprit Sahu.
Actually, he is taking continue the NPTEL degree in IIT Kharagpur, and he was taking the class of machine learning of madam, Sudeshna Sarkar madam.
Yeah, I have seen his name in the attendance sheet, but I don't know him personally. Yeah.
Okay, okay. He knows you personally.
Okay. Yeah, yeah. He might know I'm a TA in that course,
Okay, sir.
but I don't think I know him personally. But I have seen his name and also his.
He is my son, sir. Actually, he is my son.
Oh, okay.
Okay.
Oh,
I'm at the third class, sir.
oh, okay. Yeah.
He told you regarding you also. He knows you very well.
Okay. Yeah, I haven't seen
We
him
appreciate a
specifically in
lot.
the class, but yeah, I have seen his
My
name.
son like you very much. आपको बहुत ये करते हैं देखा था
Thank you.
I'm a professor in KT University Bhubaneswar.
Oh, okay. Oh,
I am interested, sir. My area is actually RF micro, but still then I am interested to learn something.
yeah.
Okay, sir. Thank you, sir. Thank you.
Thank you.
Hello,
Thank you.
Thank you.
hello, sir.
Yes.
Sir, how to score the high marks in deep learning? So tell me, sir.
How to score high marks? There is no specific answer to that. If you study each of the topics properly, then you will be able to score quite well. And there is no formula for scoring high in deep learning as such.
Okay.
Thank you. Thank you everyone for joining.